So, conceptual question about dimensions. When added several quantities, A, the quantity can have any combination of units. The quantity must all have exactly the same units, and the quantity must all have dimensionless. It means that if you sum V1 with V2, and V1 is in meter per second, V2 is in meter per second. So you sum things that contains the same dimensions, the same dimensional analysis of each one. So this means that you sum orange with orange. You cannot sum orange, 3 orange plus 4 apple. You cannot sum because they have 2 different units. So you cannot sum, for example, velocity plus acceleration. You cannot sum 3 meters per second with 5 meters per second square, because you must sum with the same units. So what is the result? What is the answer? The answer must be B. All quantities must have exactly the same units. And for sure, if you try, for example, to sum x plus d, can you sum it? No. Why? Because x is in meters, d is in seconds. So you cannot sum 3 meters plus 5 seconds. You cannot sum 3 meters plus 5 seconds. What will be the result? 8 what? 8 meters or 8 seconds? So you cannot sum it. They correspond to 2 different things. To number 2. Second, dimension analysis. When multiply several quantities, the quantities can have any combination of units. The quantity must all have exactly the same units. The quantity must all be dimensionless. Well, in this case, imagine that you have V, velocity. Velocity, the unit at meters per second. Imagine that you have mass. The mass is in kilogram. Can you multiply the mass by the velocity? Well, if you multiply, you will produce something that have new units, and the unit will be kilograms meter per second. And you can multiply quantities that has different units, like mass and velocity. Indeed, any equation that you will find in physics, for example, kinetic energy, is 1/2 mv squared. It produces a new units. The units of energy is joules, so it will be mass kilogram meters second square, or equivalent kilogram meter square second square. Or maybe you can put it like this: kilogram meters per second square per meters. Oh, kilogram per meter is kilogram. This is the unit of acceleration, and this is the unit of length, meters. So you can play this kind of combination, and you can definitely multiply 2 quantities that have different units. To the other question. Dimensional analysis when subtracting several quantities. Well, when subtracting several quantities, it happens to be the same thing that when added several quantities. The two quantities must have the same dimension. So the quantity must all have the same units. Okay, and this is the answer. And let's go to another question. Estimation, reasonable, estimate the mass of an ordinary passenger car is, well, the mass of a passenger car is 100 kilograms. This is the mass. Sometimes you confuse the mass with the weight. The weight is the force that the mass receives being attracted by the earth, and the force that the mass is reacting, the force that the mass m, the force W that the mass m is attracting through the earth is the mass by the acceleration. And in this case, the mass by the acceleration, that is g. And in this case, g is 9.8 meters per second squared. So your weight really is not 100 kilograms. It's 100 by 9.8 meters per second squared, 100 kilograms. So your weight is approximately 1,000 kilograms meter per second squared. This is your weight. And your mass is 100 kilograms. But there is a confusion when you go to the doctor and they say your weight is 100 kilograms. It's not your weight. Your weight is 1,000 kilograms in the earth. 1,000 kilograms per meter second squared. This is your weight. And your mass, your corresponding mass, is 100 kilograms. If you were at the moon, for example, your mass will be still 100 kilograms, but at the moon, the force of attraction, the acceleration of the moon, the g of the moon is smaller. So the g, it will be, let's say, 3 meters per second square. It's smaller. So your weight is your mass that have not changed, 100 kilograms, multiplied by the g, the acceleration that pull you down in the earth by 3 meters per second square. So your weight in the moon is 300 kilogram meter second square. So that's all. To another question. A speed of 65 miles per hour is the same as, well, I think that 1 mile is, 1.6 kilometers, okay, or equivalent to 1,600 meters. I'm not sure if this is exactly. So 65 miles per hour is the same that 65 miles in 1 hour, and is the same that 65 by 1 mile in 1 hour. But I know that 1 hour is 1,600 meters, so it's equal to 65. Now, instead of putting 1 mile, I will put 1,600 meters divided by 1 hour. Oh, but I have to pass to seconds this. So it will be 65 by 1,600 meters. And now 1 hour is 24. 1 hour is 60 minutes. And 1 minute is 60 seconds. So what that makes 1 hour equal 3,600 seconds. So divided by 3,000 by 1 hour, but 1 hour is 3,600 seconds. So I have converted the unit miles per hour to meter per second. And how much is this? I don't know. You do it and you see which one is the equivalent. Maybe let me erase 2 zeros here. 16 divided by 36 is like 1/2, more or less. So 65. 16 divided by 36 is like 1/2. 65 divided by 2 is like 30, 32, 32. So maybe it's this one, the C. You do it correctly, you let me know. There is another way to convert units that you may like. We'll see. This is the method. Imagine that you have 65 miles per hour and you want to convert it to meters per second. So you know that 1 hour are 3,600 seconds, 1 mile is 1,600 meters. Based on this information, you can construct what I would say the unity. The unity will be that 1 hour is 3,600 seconds, 3,600 seconds. Or maybe you can construct this unit. 3,600 seconds is 1 hour. For the miles, you can construct this unit. Is 1,600 meters is 1 mile. Or maybe you can construct this unit. The unit, the 1, this is a 1. 1 mile is 1,600 seconds. Now you go to the problem. What is the problem? The problem is to convert 65 miles per hour to meters per second. So you know that you have to end with meter per second. So you have to put here the unit that corresponds to the problem in a way that the miles will cancel, the hours will cancel, and will appear only meters per second. So you start 65 miles per hour. 65 miles per hour. Now I put the unit. The unit is this one. 1,600 is 1 mile, is this unit. I put this unit because I want to erase the miles and having having the meters. So I will end it here with the meters. Now I put the other unit. The other unit, it will be the one that take out the hours. So I will put, if the hour is in the denominator, I will look for a unit that the hour is in the numerator, this one. So the unit of 1 is 1 hour is 3,600 seconds. So 1 hour is 300 seconds. I will put the unit. 1 by 1 is 1. 1 by 1 is 1. This is 1. I didn't change. I have changed only the unit. So if I put this unit, the hour will cancel with this hour, and it will appear the second. So at the end I have 65 by 1,600 divided by 3,600. Okay, so this quantity. Miles cancel with miles. Hours cancel with hours. And what appear converted in untouched is meter and second. Meters and seconds. So the final result, you multiply now, take 2 0 out, takes 2 0 out, and it's 65 by 16 divided by 36. And remember that I'm not sure if 1 mile is 1,600 meters, maybe it's something similar, meters per second, so you check your answer. Next one. The following conversion equivalent are given: 1 kilogram, 1 liter. 1 liter is the density of a liquid is 0.83 grams per centimeters cube. The density of the liquid in kilogram per foot cubic is closer to. Let's go to do it. The other method to do the same problem is to write the unit of conversion. So we say 1 kilogram is 1,000 grams. So the unit that we can do is that 1 kilogram corresponds to 10 to the power 3 grams, because 1 kilogram is 1,000 is 10 raised to the 3. Okay, so this is one unit. Why I choose this unit? Because this unit is the unit that will allow me to cancel the kilograms that appear here, the grams that appear here, and convert it to kilograms. So I want to erase the grams, so I will use the grams is in the numerator. I will use the unit where the grams appear in the denominators. So because I want to erase the centimeter cube that is on the denominator, I will use a unity that where the conversion, the centimeter cube, instead of appear here in the denominator, will appear here in the numerator. So these are, if you see, this is confusing, but it say 1 liter is 1,000 centimeter cube and 1 liter is 0.0353 foot cube. So what it say indeed is that 1 liter is 1 liter. What it says is that 1,000 centimeter cube is 0.0353 foot cube. So I wrote the second identity, the second conversion that say that 1,000 centimeters is 0.053, but I wrote it in a more clever way that say 10 to the raised to the power 3 centimeters, which is 1,000, is 3.53 by 10 to the power minus 2, because this is 0.035. When you move the point 1 and 2, you move it to the right, you convert it in 10 minus 2. 2 times you move the points to the right. If you move the point to the left, you raise to a positive power. So in this case, we are moving the point to the right, so it would be 3.53 by 10 raised to the power minus 2 foot cube. So this is the equivalence. And what is the unity? The unity is 10 to the raised to the power 3 centimeter cube corresponds to 3.53 by 10 to the minus 2 foot cube. So we start with gram per centimeter cube, and we want to end with kilogram with foot cube. So we multiply the 1 by the 1, so gram per centimeter, so it will go like this. We use this unit first, this unit, kilogram per grams, and the second unit, centimeters, in a way that the grams will disappear, the centimeters cube will disappear, and will end with kilogram per foot cube, that this is what we want to end, kilogram per foot cube, as the problem is asking kilogram per foot cube. So let's go to do the problem now. So the problem will be like this. You start with 0.83 grams per centimeters. Now I write 0.83 like 8. If you move the point 1 unit, it would be 8.3, and you produce 10 minus 1. So this is the same than divide by 10. 8.3 divided by 10 is 0.83. This is the same. This is a scientific notation. So it would be grams per centimeter cube. So I will place 8.3 by 10 raised to the power minus 1, the 1 and the 1. And I want to convert it. At the end, I want to find, okay, let's go to do it here. 8.3, 10 to the minus 1 gram per centimeter cube. I put the unity here with the 1. The 1. 1 is 1 kilogram. 1 kilogram correspond to 10 to the 3 grams, so the grams will disappear. And the other unity is here. This is the other unity. The other unity is that 10 raised to the power 3 centimeter cube correspond to this amount, 3.53 raised 10 to the minus 2 foot cube. Okay, now what I will do, once that I have placed my problem, the problem will read like this. I will take all the numbers out, all the numbers. The 10 to the power 3, I will put it here. 10 to the 3, I will put it here. I will take it out here, and I will cancel the unit, grams with grams, centimeters cube with centimeters cube, and I will end with kilogram per foot cube. Oh, perfect. 8.3, 10 to the 10 raised to the power minus 1, 10 to the 3, now 10 to the 3, this 10 to the 3, 3.53, 10 to the minus 1. Now 10 to the 3 will cancel with 10 to the 3. 1 10 to the minus 2, 10 to the minus 2, 10 raised to the power minus 2 is 10. 10 minus 1 by 10 minus 1 is 10 minus 2. So this will make to cancel this with this, and will appear the 10 minus 2 in the denominator, so will appear 10 raised to the power 1 in the numerator. Or you multiply every possible 10 if you want. So at the end you will find 8.3 by 10 multiplied by 3.53. 8.3 by 10 is 83, divided by 3.53. It is around 24 kilogram per foot cube. This is the other method, maybe you like, I don't know. So now it's more or less the same thing that before, even easier I think. So you have 34.7 miles per gallon, and you want to convert this to kilometers per liters. This is the problem, to convert this, and they give you the information that 1 gallon is 3.79 liters, and 1 mile is 1.61 kilometers. So I was not wrong with 1 mile. So we start like this, 30.471 mile by 1 mile divided by 1 gallons. This is the initial information, is the same one. Now I will substitute 1 mile by his equivalent. 1 mile is 1.61 kilometers. So instead of writing 1 mile, I will write 1.61 kilometers. Instead of writing 1 gallon, I will write the equivalents, 3.1679 liters. So I will make all the multiplication here, and I will end with kilometer per liter. So it will be 34.7 multiplied by 1.61 divided by 3.79 kilometers per liter. So if you do the multiplication, will be, well, I have to use a calculator, but it will be 35, and 1.5 is 17 more, is like 50, more or less, 50 divided by 4. 50 divided by 4 kilometers per liters, so 50 divided by 4 will be 10, 12 kilometers per liter, maybe. The answer here, wow, the nearest answer is the A, but you do the calculations correctly. Don't trust me, I'm doing by, it's like 50, 55, divided by, it will be, yes, more or less it will be this answer, I think. I think it will be this answer. If I'm not wrong, will be this answer, okay? You do it do this problem using the unity. Create the unity for gallons per liters, gallons is up, liters is down, and create the unity per kilometer, for miles and kilometers. So kilometers will be in the numerator and miles will be in the denominator. So, so the unit that you will use is that 1 gallon is 3.79 liters, and the other unit that you will use is that 1 mile is 1.61 kilometers. So if you do the problem with the unit, well, I will do it. It will be 30. You start with 34.7 miles per gallon, and you say 34.7 miles per gallon multiplied by the first one and multiplied by the second one will produce, I hope, it will produce, instead of miles, will produce kilometers, and instead of gallon, will produce liters. So let's go to do it. So it will be 34.7 miles per gallon. The first unit will be gallons per liters. Gallons per liter is the first unit, is 1 gallon is 3.79 liters. And the second conversion is that the 1.61 kilometers is 1 mile. So now the miles will cancel, the gallons will cancel, and the result will be equal 34.7 multiplied by 1.61 divided by 3.79 is the same result that before, I hope so, but it's expressed in kilometers per liter. This is the result. I think it's like 9 should be. You do it, you do it, you do it. Here is the same result. Okay, good. Now we do this problem. It says the wavelength of a certain laser is 0.66 micron. And it says that 1 micron is 10 raised to the, if you take the meters and you divide in 1 millionth part, 1 micron is one of these tiny parts that you have divided the meters. 1 nanometer is something even smaller than 1 micron. 1 nanometer is you take the meter and you divide not for 1 million, not for 10 million, you divide by 100 millionth part. So you take the meters and you divide this in 100 million parts. 100 million parts, wow. And this part is 1 micron, 1 nanometer, sorry. 1 nanometer. If you divide by 1 million, 10 million, no, 1,000 million, sorry. 10 to the minus 9 is 1,000 million parts. Wow, this is 1 nanometers. So, okay, this is the information that we have, that 1 micron is 10 to the minus 6 meter, and 1 nanometer is